Good morning, students. Today we will start the new topic, new chapter, 6 application of derivative. And in this chapter, definitely first exercise we will not learn because it is now not in your syllabus, new syllabus. So we will start the next topic, and the topic is strictly increasing and strictly decreasing function. So focus on this topic. What is actually new in that? Look at, I tell you, strictly increasing and strictly decreasing function. Before starting the topic, I want to tell you something. Suppose you have a simple function. I'm telling you f of x equal to 2x plus 1. This is f of x I'm writing. This is suppose y. And if I tell you to make the graph of this function. So how to make graph? Okay, it's very easy. This is some value I'll take, x and y. Suppose x is equal to 0, y will be 1, x is equal to 1, y will be 3, x equal to 2, y will be 5, and definitely if I take one more value, 3, it's gonna be 7. If I make the graph, what you will feel? X, y, x dash, y dash. Plot the points. X is equal to 0, y equal to 1 will be this point. X equal to 1, y equal to 3. 1, suppose it is a 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So this is 1 and 3. 1 and 3 will be here, just near here. 2 and 5. So 2 and 5 will be like here, and 3 and 7 will be like here. So it is just, the graph will be like that. So I want to pull your attention in the case of the graph. The identity or the reading of the graph is always from left to right. See the nature of the graph. If I ask you that what you're looking in the graph, so graph is a straight line, that's fine. Then second, what you're looking in the graph, this is just to view from left to right. If you see from left to right, the function, the graph is growing up. Graph is growing up. Sometimes you can say that graph is going down. No, from left to right, as you will go on the side of x, as x increasing, as x increasing, you will feel that y is also increasing. If you're not assured, you can see in the box, x is increasing, 1, 2, 3, y is also increasing. X is increasing, y is also increasing, y is also increasing. So in that case, you can say it is actually type of strictly increasing. I will tell you the meaning of that strictly increasing, no matter at all, but look at strictly increasing. It is a kind of strictly increasing function. So increasing or strictly increasing meaning as x will move up, y is also moving same. If x is increasing, y is also increasing. When x is decreasing, y is also decreasing. The thing is what I'm telling you, that strictly increasing meaning when x increases itself, y is also increases. So this is the way of learning. I will tell you that how we can learn better. I just have taught you by the graph that whenever x increases, y is also increases, called a strictly increasing function. Okay, let me again tell you by the graph. Suppose that this is x's part and this is a simple function, graph. I am not making anywhere. Suppose y is equal to f of x is a graph and function, and it is the graph of y is equal to f of x. Suppose y is equal to f of x is any function and it is the graph of the function. Now look at the nature of the graph. It is actually the case as a straight line, as I made here. Straight line. Like what? As x increases, y is also increases, then only this structure will form. So okay, I tell you again, no matter at all. Suppose we study on 2 points. Suppose this is a point x1 and I ask you that what about this point? So one should know this is the graph y is equal to f of x. This is the graph of the function. This is the first point and suppose it is point A. So what is its coordinate? That's very simple. This is x1. So coordinate of x coordinate of A is x1. And what is its y coordinate? It is actually just by putting here. If you will put x equal to x1, you will get y coordinate, meaning f of x1. So this point will be called f of x1. So this point is x1, f of x1. And again I tell you one thing, that what about this point? This point, this is a y coordinate. This is x1, x coordinate. This is a y coordinate, f of x1. So this point will called f of x1. Very easy. Now I'll go on the second point. Suppose this point is chosen, which is actually ahead of x1, which is x2. If I ask you that what is the greater, which is the greater? Definitely x2 is the greater than x1. x1 is less than x2. So this is a further value I choose, and for this I want to ask that what is its point? It is definitely x2 and f of x2. What about this point? This point is f of x2. So see the good picture here. What you have felt? You've looking that x1 less than x2. x1 less than x2. Function will be called strictly increasing when x1 less than x2 will implies x1 less than x2 will implies, look at f of x1 and f of x2. f of x1 less than f of x2, because it is down, it is up. So f of x1 less than f of x2. The whole meaning is, as the value of x are increasing, the value of y is also increasing. Then only this kind of function will be formed. Whenever you want to see the nature of the function, students, you have to see from left to right, whether it is increasing or it is decreasing. In this case particular, you can understand that function is increasing by viewing. Suppose I make a graph here, just general graph, without any particular unit, without any particular point. One can see the graph and be assured that this is a strictly increasing function, because this is simply increasing. From left to right, you will see that it is properly increasing. Properly increasing. So this is only the definition, but concept should come in your mind that whenever x1 less than x2, we are actually examining that on 2 points, x1 and x2. I am not taking lots of points. When x1 less than x2 chosen 2 point, if corresponding values of function is also following same sign, it is x1 less than x2, f of x1 also less than f of x2, it whole meaning that function is strictly increasing function. It's very simple thing. Okay, this is the definition. This is a definition. But further this, I just want to put one example for you. Prove that function 2x plus 3 is strictly increasing. This is a question. This is a question I have taken from my side only. I know that this is not a very good question which can keep its place on exams, but still I want to discuss with you this by this definition. As you will study further, this definition will not come in often way, but initially you have to learn it. So this is only, I have taken a linear function, and question says prove that it is strictly increasing. So how we can prove it is strictly increasing? We will follow the same idea. So how we can follow the same idea? We will choose 2 points which follow this one, and we will prove this one. So how to do it? Look at solution. Let x1 and x2 are any 2 points in the real numbers such that x1 less than x2. So you have to take 2 points both real number such that x1 less than x2. And what you have to prove? F of x1 less than f of x2. So how we can do it? Let I tell you one simple method. It is x1 less than x2 we have taken from our side. Look at it, along with x what we have 2. Actually we will try to make f of x1 and f of x2 here. So we will try to make same term here. So what is along with x? We have a 2. So we will multiply by 2 both side. We will multiply by 2 both side. Now what we have here plus 3. So we add 3 both side. So all we are doing intentionally, we add 3 both side. And why we did so? If I ask you what is the value of 2x1 plus 3? So one can understand that 2x1 plus 3 is f of x1. What is the value of 2x2 plus 3? So 2x2 plus 3 is the value of f of x2. One can simply understand. So this value will be called f of x1 and this value will be called f of x2. So we had x1 less than x2 we actually took initially, and we have got the condition f of x1 less than f of x2 without making any graph. We just have to follow so-called 3 or 4 terms and we will get answer. So if you have succeed to prove f of x1 less than f of x2, meaning function will be strictly increasing functions. This is the way. And I again tell you, this condition will not be followed much in the questions. So what will be followed in the question, that only I want to speak. This was only the simple linear equation, so that we have used it. But except this, if you have something 3 power or cubic polynomial or something like a very heavy polynomial, heavy ordered polynomial, we cannot use this method. It was just for a simple linear equation, we can use it. Okay, but it was a learning time, that's why I have taught you this one. So let me rub this point. And initially, after telling you this section, I just want to improve that in some further sentences. Okay. First we are studying in strictly increasing. This is a whole concept of strictly increasing. Okay. Let me speak more. Strictly increasing, in that idea, we have learned this one. About the derivative method, actually we have 2 methods. This is very fundamental and basic method. But in second, I want to familiar to you the nature of the graph with the derivative. What is the meaning of dy by dx? This is very simple. That is instant change in y with respect to x. When very instant change is happening in the independent variable x, according to that, definitely dependent variable y change itself instantly. And that ratio, the rate of that particular change is called a differentiation. So this time x is changing itself, y is also changed. Definitely called the rate called differentiation. dy by dx. So changing itself. So okay, I tell you again one thing, that if you will make the same graph, this is a second way of learning. This is y is equal to f of x. So definitely x is changing here, y is also changing. So if x is changing, in same kind y is also changing. This changing is called positive changes. And positive changes is called f dash x is positive. F dash x, let me explain something. Dash meaning first differentiation. F dash x meaning dy by dx. It's in last chapter I taught in last exercise. F dash meaning single differentiation. So its meaning dy by dx is positive. So whenever we talk about the strictly increasing case, I tell you this is a definition of a derivative section. I will write once more definition, that function will be called strictly increasing when its derivative is itself positive. Very simple. Now keep in mind that that change is also called f dash x. That change is also called dy by dx. And whenever dy by dx is a positive, function will be called strictly increasing function. Meaning in this path all the way f dash x will be positive. So we have made a 2 definition for you. This is very basic definition which used very rare in the questions, but this is actually one of the important definition which will be used often in the exercise questions or examples question. So please keep this particular idea in your mind that function will be called strictly increasing whenever f dash x is positive. So now I don't want to repeat so-called sentences now because I already have taught you much about that. So okay, let me rub all, and now in next board I will tell you. Definitely the next section will be easy for you because it is now strictly decreasing function. I request you students, please make notes properly of this particular even the concept. Please write all the concepts in a copy. It's strictly decreasing function, so I don't want to waste the time because you already have learned a lot about that. Now very simple, I tell you, this is a graph. This is y is equal to f of x. This is a graph. This is axis 0, origin point. This is the graph of the function. Now I am choosing again 2 points. Suppose x1. This is x1. What about that point? Suppose a. So point will be x1 and f of x1 y. What about this point? This point will be f of x1. Now I am taking this point. Suppose this point is x2. So what about that point? It is x2 and f of x2. And this point is called f of x2. What you have found, this is again not a strange, because already we have learned the previous section, so we can compare now. It is strictly decreasing. So one can simply understand, as x increases itself, y decreases itself. Look at, when x is increasing, y is decreasing. It's actually falling down. The function is falling down. And I already have taught you that always see the nature of the function from left to right. Left to right. If you see the left to right, it is actually downside. So function will be called, I make a definition, function will be called strictly decreasing when x1 less than x2. Students, look at x1 less than x2. But you will see that the value of function f of x1 is upside and f of x2 is downside, meaning f of x1 gonna greater f of x2. This is actually reverse the sign. In this case called strictly decreasing function. You want to know the example? Okay, I tell you. Show that function minus 3x plus 7 is strictly decreasing. This is a question. So how to do this question? F of x equal to, solution. First I'll take 2 points, that x1 and x2 belongs to our 2 points. So x1 less, such that x1 less than x2. This is initially you have to take. But what you have to prove? F of x1 greater than f of x2. Meaning sign should be changed. So how to do? First I'll multiply by minus 3 both sides. I tell you one thing. In the case of inequality, you already read in class 11th that whenever you multiply by minus, in case of inequality, definitely change its sign. So I am multiplying by minus 3 and minus 3 both sides, but it changed its sign. You know it. Now I am adding 7 both sides. So minus 3x1 plus 7 and minus 3x2 plus 7. This is I add 7 both the side, and the 3x1 plus 7, this is gonna be f of x1 and this is f of x2. What you have gone through, like x1 less than x2 was there, but f of x1 greater than f of x2 we have got, meaning function is strictly decreasing. In last sentence we have to write. Now this was one of the simple example, but now I want to tell you the derivative definition. I don't want to write in special there only, but okay. Now this is very important definition telling you that function will be called, this is derivative definition, one of the important definition. Function will be called strictly decreasing function when its derivative change in x with respect to change in y with respect to x. This change gonna negative. F dash x gonna negative. Please keep remember the concept. This is one of the important concept ever. And f dash x is positive, function is increasing, and f dash x is negative, function is strictly decreasing. So this is the way which I wanted to share with you. The concept now I am not telling you. The use of this I will tell you later. This is not the right time to tell you. But first learn each and everything about the strictly increasing, strictly decreasing, and further which I will tell you. Learn all, and then I'll go on the next. Look at in the next I will tell you some important thing which should be known by you. Look at one very simple thing I want to share first with you. It is the knowledge of class 11th. This is the line. This is the line. That speciality of this line is a line parallel to x-axis. And equation of this line is simple. Y is equal to constant. It is passing from any point B, 0B. So any line which is parallel to x-axis is y is equal to constant. And if I ask you that what is dy by dx? On this line dy by dx will be constant, meaning 0. So keep in your mind, whenever any line is parallel to x-axis, on that line everywhere dy by dx is going to 0. Keep in mind, all the line which is parallel to x-axis, on that line particular, or all the point at particular, dy by dx is equal to 0, meaning f dash x always will be 0. Keep in mind. That is very important sentence. Okay. Now let me tell you the topic. The topic is increasing function. So what is the difference between strictly increasing and increasing function? In very fast way I will tell you this because it's again easy. This time I didn't write here strictly. So without strictly I am telling you, strictly I left and only increasing function. So what is the change between these two? Look at, I tell you one definite one particular picture, and this picture, by this picture I will tell you everything. Look at, this is x-axis, this is y-axis, and look at the graph. Look at the graph. This is a graph of the function. Look at some points. In quick way I will tell you. It is x1. Suppose it is x1 and suppose it is x2. What do you think? This is x1. So point will be x1 and f of x1. So this point will be f of x1. And this point will be f of x2. So in all, what you will say? Function will be, look at two way. First I have chosen x1 less than x2. x1 less than x2, f of x1 less than f of x2. Very simple. F of x1 less than f of x2. Don't get confused about that point. But intentionally I took first point here, second point here, and I saw that f of x1 less than f of x2. That is very same in last definition. But if I choose a one point here and second point here, so what is its value? Its function value is definitely x1 f of x1. It is x2 and f of x2. When I find the value this point, for this f it is f of x1. And for this point particular it is f of x2. What you have got? This time x1 less than x2. First condition. If x1 less than x2. But this time when in the flat area, if I choose x1 less than x2, I am getting f of x1 equal to f of x2. Look at the graph. F of x1 equal to f of x2. In two aspects, I have told you x1 is always less than x2, but f of x1 and f of x2 may get two situations. If points are here, f of x1 less than f of x2, but points are here, f of x1 equal to f of x2 will be there. So this situation, if you combine this, will make the definition function will be only increasing function. Actually, the difference between the strictly increasing and increasing only, in the case of increasing, actually function flat itself sometime at some places. But in strictly, it never flat. It is always increased. In this area, in this particular concept, function was going like that. this was flat at some region and then again increased. So it is not completely increasing, it is slightly increased at some time, it is actually constant sometime, so that it is only called increasing function. Not strictly, it is increasing. So function will be increasing if x1 less than x2, but it follows either f of x1 less than or equal to, both will come in, only changes gonna be here. If you compare the last definition, students, it will not be there. That time it was just a simple less than sign, it is equal to sign right now. And according to the derivative definition, I don't want to waste the time now. Once again, I will tell you on the same board. Look at the thing. According to derivative method, function will be called increasing if, look at here, at this particular region f dash x positive, in last board I taught you it is increasing, but at this region particular, this is actually the flat area which is parallel to the x-axis, and recently I taught you this line is parallel to x-axis, so on this whole region f dash x equal to 0, and again f dash x is a positive. So if you combine all, you will say that f dash x is greater than or equal to 0. Greater than or equal to 0. This is the definition of increasing. So please differ the last definition and this definition. In the strictly case, equal to not there. It is increasing case, it is equal to. So please keep in mind, and I don't think that I need to tell you about the decreasing function. Same it will be. So let me move on the same definition. It is decreasing function. So in quick way I will tell you, this time function will be like that. If I'll choose any point here x1 and x2, what you will feel that this is gonna be f of x1 and this is gonna be f of x2, and definition will be when x1 less than x2, f of x1 greater than f of x2, this is going to be changed. And at this point particular, and if it is x1 and this point particular, it is x2, again x1 less than x2, but is these 2 points, the value of function is same, f of x1 and f of x2. So again, same condition. So if I'll join them, function will be decreasing function if x1 less than x2, but f of x1 greater than or equal to f of x2. So it both the same. First if you got, second definitely will be getting easily. And according to the derivative definition, I tell you, this is a decreasing part. So f dash x less than 0. This is a flat area. So in this f dash x equal to 0. This is again decreased part. F dash x less than 0. Overall, I'll say, according to derivative definition, f dash x is less than or equal to 0. It is a definition of decreasing function. So this whole was the concept of strictly increasing, strictly decreasing, oblique increasing and decreasing function. So read and move according to the concept which I taught you. View for the often and often, you will get it soon. So tomorrow we'll start a new concept. Thank you.